Here's some information about how to use random numbers in Excel and how to use them to create artificial data sets. There's three basic ways to do random numbers in Excel. One is random numbers that are uniform between 0 and 1, which you do by saying equals rand. Rand is a function, so you start a parenthesis, but it doesn't care what you give it, so you give it a closed parenthesis. And you can get new random numbers by pressing F9 on a Windows machine, or Control equals on the Mac, or Command equals. You can do random integers by using randbetween, and there you have to tell it the smallest and the largest you want. So you could say randbetween 5 and 10 and get new random numbers that way. Now there's nothing that keeps those random numbers from being the same as each other. So here you can see you can get ties. The same is true for this uniform, but the chance of getting a tie to 15 decimal digits is pretty low. If you want to get random integers with no ties, usually like scramble the numbers 1 through 10 or 1 through 5 or something, you have to do it a sneaky way. What you do, so let's say this is a random scrambling of the numbers 1 through 5. I'll start with a column of rands. The first one is just the column header. So I have 5 rands there. And then I'll do the ranks of those, equals rank of that number within this data set, and I lock that data set with $signs, and the order increasing versus decreasing doesn't really matter. And then fill that down. And so it's saying this 0.16 is the 5th largest thing, this 0.81 is the 1st largest thing, and this is how you can avoid ties, because these ties in the integers, because these numbers will never have a tie. Alright, so that's the 3 basic ways of doing random numbers in Excel. So those are the 3 basic ways. Now let's look at how to use them in other distributions. So let's just generate, let's say, a few hundred of these. Doesn't really matter how many. So we'll do rand like that, and now we can make a histogram of these. Older versions of Excel don't have a histogram tool, but newer versions do. And here we go. So is that plausibly uniform between 0 and 1? Yeah, I think so. So that's our randoms uniform between 0 and 1. If we want normals, we have to say, do we want a mean of 0 or a standard deviation of 1 or what? So we can put our target mean and standard deviation up here. Let's say we want a mean of 10 and a standard deviation of 3. So here we're going to use the random numbers that we generated here and do an inverse normal formula, and we're going to do inverse standard normal, that's why there's an S here, and give it that random number, multiply by the standard deviation we want, and add the mean that we want. That's basically doing the opposite of a z-score. Z, you take the number, subtract the mean, divide by the standard deviation. Now we're multiplying by the standard deviation and adding the mean. And I could have put the rand command in here like this, but the nice thing about putting it in its own column is that later if I want to freeze the random numbers, I can just freeze these and leave my complicated formula there, and then reactivate these later. I'll show that in a sec. So let's look at the histogram of what I claim are normal. So hopefully that looks reasonably normal. And does it have a mean near 10 and a standard deviation of 3? Well, 10 is somewhere in the middle here, and down here is like 7 or so that's pretty good. We can go up and check the mean is pretty near 10. And standard deviation, I guess we should call these the target mean and the target standard deviation. And make that visible. So with 300 or so data points, we're getting pretty close to our targets. If you're curious about why we're using a standard normal inverse function, you can email me and I'll let you know. Another way to make a random variable, if you need something that's skewed right, and again, email me if you want to know why this works, is to use negative log of the random number here times whatever target mean we want. I'll go back and fill that in later. Let's say we want a target mean of 10. Oop. There we go. Here we don't get to set the target standard deviation. It's just a one parameter distribution. And let's see if we got a mean near 10 like we wanted. Yeah, pretty good. And it turns out the standard deviation ends up being roughly equal to the mean when you use this formula. And let's check that we got a skewed right distribution. That's looking pretty skewed right to me.